Okay, everybody, this lesson is on facilitated diffusion. Just by the pure name, you can see that it needs help. It needs diffusion that needs a little bit of assistance. It's going to need assistance from these membrane proteins. So let's look at first at the definition. So the definition, facilitated diffusion definition, is a diffusion of molecules or ions through a protein channel or transport protein in the membrane. And just like the other types of diffusion, it can be affected by changes in temperature. Higher the temperature, faster the rate of diffusion. Changes in the differences in concentration, high concentration to low concentration, those differences. And how many transport proteins, how many of these proteins are actually available and open, um, that also has a big effect on the rate of facilitated diffusion. So when this ion channel is open, um, where molecules can move is in either direction, really. I mean, they can go down, they can go up, but generally they're going to move in the direction of the concentration gradient. So we have these chlorine ions here, they're generally going to move down the concentration gradient here. And these potassium ions, there's a higher concentration down here, so they're going to move down the concentration gradient from high to low here. Um, so the movement of ions in this particular one, we just talked about it pretty much. There's more concentration, there's a higher concentration of chlorine here, they're going to move down this direction. There's a higher concentration of potassium here, they're going to move up in this diagram. Okay, and I also want you to see the difference in the size of these channels. It's not just size, but there is some real specificity as to which ion can go through which channel. Okay, let's talk about these things called gated channels. Now, the difference is that the gate can be open or closed, and it almost has like a lock to it. So some channels that are gated, they can open and close based on the conditions around the membrane. They can change based on the temperature, membrane potential, or the presence of a ligand. So in this particular case, if there's a high enough concentration outside of these ions, this causes what's called a membrane potential or a difference in the charge. So the higher positive charge out here, and therefore this is going to seem negative down here. The higher difference that is usually can cause the channels to open, or you could have a ligand that actually sticks into this and will either open or close it like a lock. So let's talk about a particular situation involving chlorine ions and actually aquaporins as well. So aquaporins are almost as a type of facilitated diffusion, but it's a type of facilitated osmosis, if you will. But we really don't refer to it as that. But here's a normal lung cell up here. So let's talk about this. And people with functioning chloride channels, the chlorine channels, chloride channels are open so that chloride ions can flow out. And as the chlorine flows out, the water molecules also flow out. Remember, they kind of follow the solute. So they follow, sometimes you say they follow the salt. When this allows a mucus that builds up outside of the lung cells to kind of just be diluted by the water a little bit more. Okay. Now, if we have someone with cystic fibrosis, you'll notice this channel protein has this block here. So individuals with cystic fibrosis, their chloride channels don't allow the chloride ions to flow out of the lung cells. So they are stuck inside the lung cells down here. So these chloride ions build up, the water continuously is flowing in. This makes this outside of the surface, the airway part, very thick and not like, think of like syrup versus a watery kind of solution. It's easier to remove the watery, where there's more water than it would be that syrup. So this sticky solution and mucus forms in the inside. It's very difficult to get that out, and that's why it's in a good environment for individuals, or I'm sorry, it's a good environment for bacteria to survive in this thick mucousy area. So a lot of things happen because of that. This sticky mucousy buildup in the lungs, pancreas, and other organs. We most often talk about it with the lungs, but there's other organs as well. There are frequent lung infections because of those bacteria that love that mucus. The mucus can also affect how the pancreas releases digestive enzymes, and they have somewhat salty tasting skin because the salt is always on the surface. There's very thick surface. Okay, that's it.